Hello, everybody. My name is Maxime Dehaut, and I'm the marketing manager at Codit. I would like to welcome you on this webinar on AI-driven fraud detection. Now, the goal of today's session is to make you discover how AI-based solutions can mitigate fraud, reduce losses, and in the end, help your business remain competitive. The hosts for today, because there are two, are Maxime Dehaut and Frank Roessig. Maxime is our lead architect at Codit Luxembourg, and he's helping our customers to define their technical strategy when it comes to data-driven solutions such as IoT and AI. And Frank, he's the head of cloud applications, data and AI at Telindus Luxembourg, which is a sister company of Codit. He focuses on delivering innovative solutions built on technologies such as AI, blockchain, and cloud. Now, before we get started, if you have any question you might have during or after this webinar, please use the Q&A tool. We'll monitor this, and at the end of this webinar, Frank and Maxime will take the time to handle your questions. And with that said, Maxime and Frank, the floor, or the virtual floor at least, is yours.
Thank you so much for the kind introduction, Francis. Max, great to have you here today. I'm very thrilled to hear from you based on your long experience in the AI field. So we're gonna first talk about the context and about AI fraud detection, why we're actually looking at this today. Then we're gonna talk about a few use cases, and then we're gonna provide an outlook of where this is going. So if we look at our next slide, we will see that basically online transactions have been growing hugely. But not only have online transactions actually grown hugely, but the percentage of mobile phone, smartphone-based online transactions was probably the biggest source of growth. That means that fraud has evolved from being a classic type of fraud and online to really a mobile phone fraud. If we go to the next slide, we will see that actually not only has the structure of fraud changed, i.e. gone increasingly online and increasingly mobile phone, but actually the attempts, the volumes have really increased. So while the fraud amounts per successful fraud per $100 have slightly dropped, the attempts have increased hugely over the years to get the fraud rolling basically worldwide, right? And we clearly have a projection that fraud will continue to increase. This is an indication very simply that actually fraud is a lucrative business, right? Now, if we look at the next slide, we will see that the fraudsters have become increasingly sophisticated. So what are we talking about? I mean, they're skimming, we said about 2018-19, 4.23 trillion of us. And how have they become more sophisticated? Well, one is basically they're doing smurfing. So smurfing means that they will skim small amounts, they'll skim broken amounts, where in the past fraudsters were actually taking a recurrent amount. They'll take amounts that are broken, that change every month, so that simply it appears to be less visible for somebody looking at their account statement or a company looking at the expense and all that stuff. The other thing fraudsters are doing, they're increasingly actually creating what we would call synthetic IDs. So they create programs that will behave, more or less like a human, mimic some type of behavior, and go ahead like this. That means, again, it makes it far more difficult to detect. While in the past there were simple rule-based engines that were skimming a few cents from accounts or from basically payment pipes every month. Now it's like a semi-smart algorithm that will do something one month, then nothing the next month, and the months afterwards it will appear again, right? Things like that. So they're really becoming increasingly sophisticated. Now, if we look at the next slide, not only are they becoming increasingly sophisticated, but actually it touches every type of business. Obviously, financial services is clearly what everybody thinks about, money transfers, and yes, these are probably among the biggest, targets. But e-commerce is hugely hit. It's very tempting, and as we know that in recent times a lot more people have gone online, it's even more tempting, right? the utilities business is touched very often. People are sometimes surprised to realize that in fact they paid, 14 utilities bill over the year. That doesn't make a lot of sense, but actually in their daily business activities that they haven't noticed that. Insurance is also increasingly touched. Why? Because increasingly policies are not paid one-off. They're paid like in small amounts every month, things like this. But it also touches things like airline ticketing, fake taxes that are somehow invoiced separately, etc., etc. So it touches a broad set of industry, and it does actually not only touch basically the B2C, but it also touches basically B2B activities, right? So, Maxime, I mean, we know that AI is part of the solution here. Where are we, in fact, in terms of AI adoption?
Okay, thank you, Frank. So if we move to the next slide, what I've tried here to represent is a conclusion actually of a set of surveys and report published since 2019. And it obviously focuses on AI and ML adoption. So what I would like to do here is to focus on the three item of statistics on the bottom left side of the screen. So for instance, the operationalizing model. So what happens is that it sounds, or it looks like 1 out of 5 models get ultimately deployed in production and stays in production for at least 3 months. So I think no one will disagree with me that it's not a lot, and there are a couple of reasons for that, and it's very interesting and actually crucial to understand these reasons. So one of them is the lack of what we call similarity between the development environment and the production environment, and this is something we're going to address a little bit later. Another one is data leakage. So this is again due essentially to a lack of practice, and this means that the training data don't really match what you have in production. Then you have bias, you have also a lack of regulatory compliance, so this is the famous Article 22 of the GDPR. And then you have another concept which is quite an interesting concept called concept drift, and that simply means that your distribution has changed in production since the beginning of the development process. And that, again, that's essentially related to the length of development time. So there are lots of reasons here. The next statistics is also quite interesting. So only 25% of the surveyed organizations have in place again, robust model management practices and processes. So this is not necessarily reassuring, considering the importance of these practices. I've touched base a minute ago, and again, we will address that a little bit later. Now, the last one, and Frank, I think would be interesting to hear your opinion on this, because I believe that it's related to digital transformation, but it basically says that most of the initiatives are not driven by the business side, but by the IT side. Mm-hmm. Frank?
Yeah, absolutely. And it's a bit sad because so the IT clearly sees the needs, but the business side doesn't. And the reason is, whatever you do in this field in terms of fraud detection, you got to integrate it in the digital transformation of a company, and that creates awareness. So we talked a lot of people who are actually doing digital KYC, AML management, and very often they start with the onboarding of the client, with the start of the relationship with the client and managing simply client information. And once they're done with KYC, i.e. know your client or your counterpart, then they look at the transaction, which makes sense because you first start basically normally by onboarding a person, then you look at their transactions. Having said so, the regulators are becoming increasingly stringent in saying that they want to see what they call STRs, suspicious transaction reports or suspicious activity reports. And since there's so many of these transactions that happen when you onboard a client, basically you have no other choice but to go AI.
Okay. So if we move to the next slide, and I think it's a good time to start talking about fraud management. And one thing I would like to mention is that fraud management is always different depending on the sector. Having said that, fraud management relies on, I would say, 4 types of activities, which are prevention, detection, treatment, and recovery. So prevention is a critical phase. It's actually most likely the first phase you will have. And this is where data scientists and business expert will build and evaluate your models. And I insist on data scientist and business expert. It's crucial, as we've just mentioned, that the business side is involved in this process. This is where you will implement or design your known fraudulent patterns and behavior. But it's also here that you will try to analyze the unknown. So here the idea is to run some kind of algorithms that will highlight some patterns that you don't necessarily know or you're not aware of. And again, your data scientist and your business expert will look at them and try to identify these patterns and make sure that they or not make sense. So that's the idea here. After the prevention, we have the detection, and this is fairly straightforward. This is where your models will get executed, whether it's in production or, and that's quite important, in simulation too. So it's crucial, and again, we're going to discuss about this a little bit later. It's crucial to have a kind of simulation environment where you can evaluate your models independently, but also within a business strategy. And then last but not least, you have treatment and recovery, and they speak for themselves.
Mm-hmm. So if we want to stay with prevention and detection, and I'll stay with the use case, you start a relationship with somebody, right? That's where your risk starts. And then basically that's that person, whether a business or an individual, starts acting, right? Give us a bit more details. So how do you prevent once you start that relationship?
Okay, so there are three types of activities, actually. There are data-related activities, operation, of course, and then practices. So the data is fairly obvious. Yeah, this is where you capture your information, whether they are submitted by the customer or you collect that from an external system, and that's typically collection. You transform these data. Why? Because particularly when you collect from an external system, this system has its own data schema, data format that you would like to adjust to your own format. And then this is also where you understand your data, whether or not they are at rest or in transit. And this sounds technical, but it isn't, and it's quite important. Fraud is not necessarily real time, so it's not necessarily about data in transit. It can also be detected on data at rest. And actually, from experience, most of the fraud detection mechanisms are applied on data at rest. So why is it important to make the distinction between the two? It's simply because whether you use data at rest or in transit, it will have an influence on your infrastructure, therefore your investment cost, and also the type of model, and that will have an impact on the delay.
So concretely, if I manage to get into your data at rest saying that actually I don't live in London, but I live in Santiago, suddenly it may become very normal that I start doing transactions in Santiago, right?
Correct. And this is not ideal.
Yes, okay. So something that would have been detected as suspicious if it hadn't changed the data becomes actually something totally normal. Absolutely,
yeah, okay. Absolutely. Yeah. So if we move to the next, not the next slide, but the next point, sorry, apologies for that. So the next point is operation. And again, this is very similar to the detection activity or phase we've described. So this is where you include the development of your model, the training, testing, evaluation, the execution, and more important than all the others I've named, surprisingly enough, is the monitoring activity. Yeah. Today, you cannot afford to have a system which does not monitor your models.
If we could stay on the prior slide, actually, I think that's really important because there's this recent study that found that on digital platforms, and we all know they become increasingly important, that basically false positives in 60% of the cases create friction points, i.e. if for some kind of reason I'm being blocked or my transaction is simply being slowed down because it's considered to be suspicious, but actually it's not suspicious at all, my digital experience is impacted. I'm unhappy. And in this world, as we know, a lot of users are really about striving for immediate gratification. I want to do a few clicks and get whatever I'm asking for. that's why you need to do this monitoring, right?
Yes.
Tell us a bit what's happening there and how you can avoid these kind of frictions that is really disliked by users.
So there are a couple of things here. Bear in mind that we are in the context of AI and ML. But you're absolutely right. Ultimately, what you are monitoring is the activity of the entire process. So we have different techniques. One of them, for instance, is to monitor, so to keep an eye on, for instance, the number of cases decline suspicious or flag as suspicious or valid, and you monitor the evolution of that. And of course, if there is a peak in the number of suspicions, then something is wrong. But also, and that's another good reason to have a monitoring is, if you have a peak in the case of a suspicious case, that means that behind the scene, your team will have to deal with that. So the question is, do you have a flexible team? So does that mean that you can bring on more people who will deal with this peak? Most of the time, it's not the case. So what you want is to put in place measures. And again, a good example of measures is to bring another model that will monitor the activity of the first model.
So what's interesting, what I'm hearing here, on one hand, you want to monitor your AI to see, okay, actually, how many frauds has it spotted and not spotted?
Yeah.
How efficient was it and mitigating risk? But you should probably plug it into a system that provides data, for example, like how many of your clients have dropped off.
Yeah.
So if basically you increase by 10% the fraud you detect, but your clients are dropping off, more by 50% more, there's maybe a problem here, right?
Absolutely, yeah. And that's what I was mentioning earlier in the detection phase, where you having a production environment is not enough. You need a simulation environment where you will do what-if analysis, real-time monitoring, etc. Mm-hmm. Absolutely, yeah.
So I could look, okay, if I save 10% of fraud, that stays here in amount X. If I lose 50% of my client onboarding, that makes me lose an amount Y.
Yeah.
If X is lower than Y, actually, I'm better off tolerating more fraud.
Absolutely,
okay.
Yeah. Absolutely.
Yeah, makes sense.
The last one I wanted to address, so on top of the monitoring, which is critical, is the practices. So this is all the activities, not only governance, but you have to see the practices as a set of safeguards that your organization will benefit, and it will facilitate the deployment or the development, and the deployment of your models. But again, I think we'll go into further details, I think, in the next slide. So if you could move to the next slide, please. Okay, so far we've been quite high level. I think, Frank, you wouldn't disagree with me. So let's go a bit more into the details. And again, I wanted to keep these three type of practice, so type of activities. So data, practices, and operation. And I've just drilled down a little bit further with the different activities you have within these three blocks. So the first one is, again, related to data, and it's everything related to ingestion and enrichment. So if you remember what I said earlier, what you're looking at is to have a kind of set of connectors, and these connectors have the capability to collect data from various sources. The idea here is that the more diverse your data are, the richer your model will be. That's crucial, and I mean it's clear for everybody, I guess. What is important is that, again, for your data scientists and business experts, who are not necessarily IT people, but they are keen to build these models, is to have access to these connectors, and these connectors should require a minimum configuration. Now,
and if I might chime in, it all starts also with validating that the data you ingest is correct.
Absolutely.
If you have a lot of blanks in certain data, you need to normalize the data so it's easier to analyze.
Yeah, so I was about, so and this is included into the ingestion and enrichment. So this is what we call also the data cleansing or data transformation or data wrangling. There is a lot of terms there. The idea is to make sure that you are comfortable with the data you're about to process. So a good example is this, and I've seen that many times with various customers. They have many different systems. They collect information from different systems, and of course, each system has a different data schema or data format. The best example is the date format, where sometimes it's year, month, day, other times it's day, month, year, etc. So what you want is to have some kind of consistency here. So the idea here is to have a set of scripts that will convert the data from an unrecognized format to a recognized format. That's the idea of data ingestion and enrichment. Now, in terms of tools, because I know that you're going to ask me that, Frank, if you're familiar with Azure Data Factory, it's most probably the best example I can give to you. Is a very good platform that allows you to do ingestion and enrichment. Now, if we move to the next slide, sorry, I should stop saying that. It's all about exploration and visualization, and this is a critical phase where you will spend, or your organization will spend most of the time. It's actually data scientists and business experts spend more time there than in building the models for various reasons that, again, we'll address a bit later. It's all about understanding the trends and the patterns, whether you are aware of them or not. So that's a mistake I've seen in the past several times, is data scientists and business expert, they are aware of certain or some patterns, and they tend to ignore them, assuming that they're already there. Mm-hmm. That's a mistake, and that shouldn't happen. So you always have to start with what you know, and when you've built that, then you move to what you don't know.
I guess that's the whole purpose of AI. If there's nothing new you will learn from it, you wouldn't need it, right? The whole idea is that actually the machine will show you stuff you don't know. So patterns will emerge that you have not expected. Yeah. You obviously need to verify it. So actually, fundamentally, as an organization, you should be ready for the unknown, even if it's counterintuitive, right?
Yeah, absolutely.
Mm-hmm. I have an example, if I may allow. So big English banks have basically monitored phone banking-based fraud, and they had always assumed that actually a lot of fraudsters were actually stationed somewhere abroad, and they actually noticed that most of them are actually in country.
Okay.
Which is why they missed them, because they never expected them to be really so risk-taking that we actually sit in the UK doing that, right? Yeah. So here you go. It's AI to help them detect the fact that they were sitting not far from the bank, actually.
Yeah. Okay. Interesting. Okay. And then, so to finish on exploration and visualization, again, I'm going to mention there are a couple of tools on the market. Power BI is one of them, and it's quite helpful. In terms of operations, what you're looking at, and that's crucial, is a platform offering a set of commodities. So the best example to that definition is a cloud platform. You have a lot of commodities like storage, computing, etc., that are provided by default. And on top of that, you will reuse these capabilities, and on top of that, you will build your solution, in this case, fraud management. So now you have different layers, of course. You have authoring layer. So this is, again, fairly straightforward. This is where you build your models. And again, so far I've been talking about models. We'll see that there are different types of models. Maybe it's the right moment to mention that. So we have what we call rule-based model, and then the analytical model. So because you have a model and you're authoring them, then you need also an engine, and that's why you have rule engine and analytic engine. You need an execution environment. So as you can guess, it's not all about the rule-based model or the analytic model. There's some kind of orchestration that are required. You need a case manager to deal with the suspicious cases, etc.
And I think the case manager is important, because it's through case managers that you actually validate whether a fraud is a fraud. Yeah. And that helps the system to learn.
Absolutely.
Like we talked prior about the false positive, negative. That's where basically you identify those and make sure that actually the learning takes place. Right?
Yeah. And this is where you circle the loop. So you're absolutely right. The case manager is the last step before it goes back to the data scientist, and they will cross-check the feedback from not only the model, but also the analyst. Absolutely. So the last item I haven't spoken yet in terms of operation is the pipeline layer. And that's probably the most important one, where most of the organization, I won't say fail, but are a little bit behind. The idea here is that if you consider that it takes roughly between, I think the numbers are between 90 days to 6 months to, from the very beginning of the development process to the deployment, that's a long time. And most of the time is spent on data exploration and visualization, which is fine and which should happen, of course, because ultimately what you want is make sure you understand your data. But then the rest, if you look at the rest should be automated, and that's where pipeline come to place. Unfortunately, it's not the case. Quite often, organizations still expect from the data scientist, business expert to copy files, to do manual intervention and things like this. So it takes a lot of time. It's also not extremely compliant, because what an auditor will ask you is, it will probably ask you to show you the storyline of your model. So who's done what on the model, etc. So the pipeline is also deeply linked with practices like governance, etc. So it's crucial to make sure that you have a pipeline capability or pipeline layer. There are some standard practices on the market, or like DevOps for the software systems, MLOps for which is more specific to machine learning. Again, you have one on Azure that cover both.
Mm-hmm. Azure DevOps and MyOps, right?
Correct.
Yeah.
So the last one, I've already touched base on that, is the practice. So the governance, I think everybody knows that this Article 22 and the right to be explained, and so basically every decision that has been taken based on a model, whether it's a rule-based or an analytic-based, has to be explained if the customer is interested. So that has to be addressed. That introduced the notion of explainability. Now, just to be clear, you might ask me, is it mandatory to have an explainability capability? The answer is no, but if you don't, then the question is, how do you explain your model if a customer knocks on the door? So that's something that has to be investigated. Monitoring, we've touched base on that. And then the security, that's also a quite broad aspect. I will just mention two things. First of all is you need to make sure that your pipeline, so the process that takes the model from development to deployment, is secure. That's one thing. But then maybe a more technical aspect is that a model can be fooled, believe it or not. And you will need at some point to prove to the auditor that your model is secured enough or robust enough. Mm-hmm. Okay.
Yes, you need to protect the model. So we had a case also where actually it was a bank working with a lot of intermediaries, and some of them were actually submitting using like many different names to submit a very similar credit application just to see how they could game the system.
Absolutely, yeah.
And you know, they thought they're being smart. Well, through AI, you could detect it. Actually, you know, it's always more or less, although the name changed, a similar submission, and somebody's going to try and optimize the system, right?
Yeah.
And that's where security is important. Yeah. So when we go from there, Maxime, I mean, you know, should we expect that any AI platform has all these functionalities?
No,
a lot of stuff, right?
It is indeed. Now, the good thing is that today most of the platform, thanks to the cloud technology, have all these capabilities. Whether you use them or not, that's your decision. But if you think about what we've been talking so far, apart from maybe from security and explainability, and even that one is debatable, all of them are quite mandatory, I would say. Yeah, I think the question is, how far do I want to go? And I think that's the key question is, I would recommend that you put all of these in place, but start low and then progressively increase the level of complexity and sophistication. Mm-hmm.
So certain platforms, you mentioned Azure, can also help you basically by acting as supporting engine for these, right?
Mm-hmm. Yeah, so
talking about algorithms and things like this, you may not have to reinvent the wheel there. Yeah. You could use what already exists. You can also have basically a tool helping you to build a pipeline.
Yeah, absolutely. Yeah, so you have these tools, and some of these tools are actually quite cool and easy to use. So I'm thinking, for instance, of Azure Machine Learning Studio, which helps you, so you don't need to be a rocket scientist to use it. A data scientist will do. And you are driven by the tool on the different tasks to follow to be able to build your model. So that's extremely handy. That's one thing. There are other technologies. So I'm thinking of, I don't know, Frank, if you've heard about AutoML, so automated machine learning. So the idea here is that this technology will collect information from you. So there is a part of the pipeline which is handled by it. We'll search for the different algorithms based on different data distribution. We'll execute the best model, and ice on the cake, we'll justify or explain to you why the model that has been picked is the best. So that's, again, that's extremely handy for different reasons. So let me share with you an experience. I had as a customer a very large bank in the UK, and they were using AutoML. So there were a bunch of experts in machine learning, but they used AutoML to actually pre-filter, so to pre-select the different algorithm they would use. So in other words, instead of going through 10 algorithms and decide which one they should go for, they will go for the top 2 given by the AutoML and work on them. So that's another approach where you save a huge amount of time. And it's maybe something I haven't mentioned earlier, but I think it's worth mentioning this. So I think I said that it takes a decent amount of time to push to production a model. And the question would be, why is it so important to push as quick as we can a model to production? Today, it's clear that the data distribution in the data changed very, very quickly because the customer behavior changed, technology changed, and even regulation today changed very quickly. So more and more what we see from our customers is that they can't cope with the change in the data distribution, so they're always behind. And that's probably explain also the statistics that we've seen earlier about the 20%.
Okay. I think there's maybe another factor linked to that too. If you want to first aggregate all the data you have, create a huge pipeline that covers 100% and so on, it may take you a lot of time and effort before you actually see the value that's being generated by your AI. In our experience, very often it's fairly beneficial to say, why don't we carve out a bit, focus on it, and actually in a short time frame, short to our organization, that actually AI reduces fraud and does not destroy client experience at the same time by X%, let's say 20%, on a small data set, on a small chunk.
Yeah.
And that often creates the buy-in you need to grow it from there. And it also does create the learning that you need within an organization to basically grow with the AI, right?
Yeah, absolutely, absolutely. So talking about growing, and if we move to the next slide, I think most of the time, what we see or what I've seen is that organizations have already a rule engine in place. So they apply, and I hate to use this word called basic, but they've basically implemented into a set of rules the known patterns and behaviors.
So how I mean, concretely, how does that look? So every amount that's 100% bigger than what decline usually does, raise a flag, things like this.
Yeah, there is that. There is also, for instance, the number of transactions during the day, the day of the week. So that's quite a famous one. In retail, but it's also valid in financial services and sometimes in insurance. The day of the week is crucial, but also the information you can collect from a technical perspective. So, for instance, the IP range is one. Is the customer behind a proxy? If yes, then that's be worried, and all that kind of things. Another good example is, and I can relate to a case where the customer was asked to fill a form. It takes at the bare minimum 5 seconds to fill the form. And so, which means that every transaction that comes and it took less than 5 seconds to submit, then there is an issue. So it's a kind of really basic, you could say, but again, if you don't do it, then you're already in trouble, right?
Yes.
So
these are all these people who are suddenly on holiday and get their cards blocked because they're in a different country, and if you realize that, that's actually the moment I want to spend money with my family, right?
Yeah, absolutely, yeah. So I'm tempted to say that the rule engine has to be seen as a kind of, it goes around a model or a set of machine learning models, and it reinforces by applying, and again I quote, the basics. Yeah. So the question is, what should I do? Because if I already have a rule engine, can I not just take an existing machine learning model and drop it into the rule engine and job done? So I think first of all, can we do that? And the answer is obviously is yes. So there are several rule engines available on the market that have that capability. Now the next question then is, should we do this? And my answer is fairly direct, and I wouldn't recommend it. So there is a trend at the moment which basically says you should externalize your machine learning model out of your rule engine, okay? And for various reasons. The first one is quite technical, yes and no. It's all about uncertainty. So a rule-based model has no uncertainty. Yeah, it's a deterministic model. But a machine learning model is based on randomness, or at least at some level of randomness. And therefore, if you put your machine learning model into your rule engine, you induce some kind of uncertainty in your rule-based model. Auditor doesn't like that, but also, again, it's very difficult to explain. Yeah, so that's one thing. The second thing is, as I said, the trend is to have as a service, and it's valid for machine learning, but it's actually valid for many things today. But the benefit of having a machine learning model exposed as a service is that it can then be consumed by different systems. So let me take an example. If you have a model about your customer behavior, it could be used in fraud detection, it could be used in marketing, it could be used in customer management, and so on and so on. So you build one model and then it's reused by multiple systems. Every time this model is updated, you don't need to tell anyone it's going to be automatic. So it's extremely handy.
So I would anticipate this is a time gainer, right? If you have a solution that's heavily rule-based, it's actually only after you have had tons of frauds, of new frauds, that you suddenly realize that your engine is behind. Now, by enhancing this with machine learning, you should actually detect these new patterns much faster, right? And be able to adapt much faster. So one of the advantages of machine learning is faster detection of new types of fraud. Would that be a fair statement?
Yeah, it would be, yeah. And just to complement what you've just said, it is possible to acquire or to get some predetermined or pre-existing models. Yeah. And so if you don't have volume, which can happen, right? Because when you build your solution, you didn't think about this, you can still acquire some models and include them into your system. And another interesting point is today, and this is mainly due to or related to governance as well, is the auditor wants your organization to be, and particularly some of the teams, to be accountable and to have ownership on the different models. And this is where the difference starts. And so far I've been talking about data scientist and business expert. Normally, and what I've seen in the past is that business experts are accountable and are the owner of the rule-based model, because this is where your business strategy is defined. In terms of machine learning, this is more the data scientist. And usually within the data scientist team, you also have a business expert who can advise them, right? Mm-hmm. So by externalizing your models or splitting these two models, rule-based and machine learning, you make accountability and ownership more obvious, and auditor likes that. And last but not least, but we've just touched base on that, is the feedback loop. So what you collect from one system can be reused in the other one. Mm-hmm. Does that make sense so far?
So far, it makes a bit of sense. So I mean, let's be we have this basically. I see it more as an ascension, basically, right? I mean, let's talk a bit about the future of AI and how this actually moves on. So we have a slide with some very nice balloons on them that will basically show us where all this is going. You know, it's dynamic. So it starts at a given level and then moves on basically in terms of complexity, but also in terms of efficiency.
Yeah.
Why don't you get started, Maxime? Where are we today? Right?
Okay.
And most kind of where do people start in basically with AI? Where are they moving to, and what's actually next on the agenda?
Okay, so there are two things to consider here. There are the level, what I call the level of maturity, and the level of sophistication. Mm-hmm. So the level of maturity, which is on the left-hand side, is, in other words, is how familiar your organization is with machine learning concepts. If you are extremely new, of course, you would not start with cognitive analytics and things like this. Mm-hmm. On the other hand, so on the other axis, you have the level of sophistication required by your business. So what I mean by that is it really depends on what type of business you have. Are you on the transaction fraud? which has a higher volume, higher velocity of the data and things like this? Or are you on the invoice fraud management, for instance, which is slightly different as well? And for which case batch would suffice. Mm-hmm. So
and sophistication is probably also sophistication of your enemies, right? The fraudsters.
Of course, of the market. Absolutely, of course.
So the first one bit of what you said is how much can you basically take from you, right?
Yeah.
Taken from you. How fast, right?
Yes.
If your payment processor can very fast, and how smart is the other side? Got it. Yeah. Okay.
So you start with rule-based analytics models. That's what we've been discussing so far. And then you will slightly move to this AI machine learning platform. So if you remember, this is where you have your pipeline, the practices in place, monitoring and things like this. And then there is a kind of a decent gap where you will apply explainability, fairness, diversity, governance, all these nice but quite complex things to put in place. Mm-hmm, mm-hmm. And then if you're already there, then the next step is cognitive and probabilistic analytics. But that's
so let's stick with CTI, cost to income, right? The green balloon. So what does that give more compared to the AI ML platform?
Okay, so CTI, you've basically given us an example earlier. So imagine that you have a transaction and you've identified that transaction as potentially fraudulent or highly potentially fraudulent. Mm-hmm. So what you want to do is to assess what would be the impact in my own business if I actually let that transaction go, because if I let it go, then I can carry on and see what is the behavior of the fraudster, and then I can reuse that. Mm-hmm. Another good example for CTI that are used, particularly in the UK, is imagine that you go to your bank and apply for a product. Yeah. What the bank will do is a kind of optimization, obviously, is try to determine they will not consider that the product you would like is necessarily the best for you, but also for them. And that's a cost to income, CTI. They will apply that kind of thing. So that involves obviously machine learning models, but also sometimes optimization models.
Mm-hmm, mm-hmm. Okay, taking some broader aspects into consideration. So how does it become cognitive from there? What's the added value there?
So
it's not going to let you off the hook that easily.
No, of course not. Okay, so cognitive is we have that more and more, and actually you probably know better than I, because digital KYC is a good example for that. As soon as you have a dialogue, so I have two examples. The first is as soon as you have a dialogue with the customer, like a chatbot or things like this, what you want is you want to understand the customer, and ultimately what you want to reach is like some kind of compassion with your customer. So you want to make sure that the answer you will provide to your customer will not hurt him, and you will keep him as a customer. That's one example. Mm-hmm. Another good example for cognitive analytics is when you process your log files. And so typically a log file is just a set of numbers and blah, blah, but it's very difficult to write a story about all these lines in your log file. So this is where you can use cognitive analytics with a little bit of reasoning behind. And then suddenly by doing that, then you build a story, and that story might be the different steps a fraudster is using to try to cheat your system.
So actually it's interesting. So yes, we have this whole process on client onboarding.
Yeah.
It's built on different modules.
Yeah.
And depending on the suspicion we detect, suspiciousness we detect, like, we may add or reduce the modules.
Yeah.
Right. In a manner that's totally invisible to the client. A petty example is they may have scanned their passport, but we still quickly ask them retype their city of birth, which anybody who does this by heart does it in 2 seconds. It has no impact really on the process for them, but somebody who has to find it out because they're doing social profiling is going to take much longer.
Yeah.
And we're going to detect the way they type and do that, right?
Yeah.
So that's a good example where you adapt the process to this, the moment of suspicion or any elements that come on. No, it makes a lot of sense.
Great.
Why don't we go to the next slide? So to wrap it up and leave some space for questions out there.
So if I remember, I had 2 slides about which go a little bit further into the details in terms of practices. What I suggest is I'm quite conscious of time. I've said a lot of things. Should we just move on straight to...
Yeah, AI design experience, right? Okay. Let's wrap it up with that.
Yeah, once we get there, I just would like to finish with something. I like finishing my presentation with a quote. And what we've been discussing during this webinar, Frank, is all about operationalizing your model. Yeah. So I just would like to quote a professor from Cambridge University who used to say, this guy is now leading the AI at Uber. You can have the best model in the world in your vault. If you don't manage to operationalize it, it's worth nothing. And that's really what should be the thing that drives you every day, is make sure that your model will ultimately land into production.
Yeah, exactly. And it will have to produce something that creates value for you, right? It's going to reduce your costs. It's going to improve your client experience. It's going to make you more productive. Something must be tangible there. Right. So if we wrap it up, right? I mean, you're here to help, Max, right? At the end of the day.
Am I?
Yes, you are. So how can you help organizations that want to get started and or create value through their data?
So typically what we would do is we would recommend to have a kind of workshop with a customer to not only understand what these guys are doing, but where they are, what if they tried. Yeah, quite often customers have already tried, but either it doesn't work as they want, or they have the feeling that they could do better, or simply do differently. So that's the purpose of a workshop, and also understand what can be done, etc. Then we try to illustrate that with real world use cases, so things that we have done. And again, you know, the example I was giving about the retail world, where they use information coming from your IP, for instance, it's a very valid example, because now it's used in many other sectors. So again, what we try to do is to narrow now on the second step, is narrow where we're going. Then, of course, I don't know any customer who's going to buy with anything with closed eyes. So the idea here is to demonstrate that not only we have the knowledge capability, but we can elaborate a solution that is fit for purpose. And this is usually done in parallel with a kind of proof of concept. And lastly, at Codit, we brought our large experience in Azure platform. Does that make sense?
That makes absolute sense. So you can basically start on a small scale, you know, and go from there in terms of proving that AI ML really helps you. With that, well, thank you so much, and we can move on to see if there are any questions out there.
Yeah, indeed. So thanks, Frank and Max, for sharing your insights.